So here we go with another problem. I think this is problem number 6 from section 4.4. Okay, so here we go. Number 6 refers to a right circular cylinder. Okay, and the volume. It talks about the volume. It also talks about the surface area. So we better know those formulas. And so of course, a right circular cylinder is just like a can. Okay, the base of which is a circle, and which is carried out through height h. Basically, it's called a prism, if you remember from geometry. And the volume area of the prism is the base area times the height. So the base is circle, the area is pi r squared, the height is the height h. Okay. Now, we're asked to express the total surface area as a function of the radius. Okay, so the problem here is, of course, the surface area formula. Again, we should know that. That's the amount of material needed to create the can, as it were, which is, okay, the bases, which are circles, and there's two of them, so it's 2 pi r squared. And the lateral area, which would be the perimeter of the base, times the height, as given for any prism. The lateral area is the perimeter of the base, which is, of course, the circumference of the circle, 2 pi r h, and 2 pi r times the height h. So here's our formula for lateral area. Here's our formula for volume. Now, we're told that the volume is 12 pi. So we can take this formulation and we can set it equal to 12 pi. And of course, from there now, we need to find the surface area as a function of r, which means in our surface area formula, we have to get rid of this h, because then we won't have surface area as a function of the radius. So we'll come back to this volume formula, and we can solve that volume formula in terms of r, okay, or h in terms of r, rather. And quite simply, the pi's are going to cancel out, and h is going to equal 12 over r squared, which we can now just substitute into here, and that gives us a surface area as a function of r. So it's 2 pi r plus 2 pi r times effectively 12 over r squared. So we clean that up, it gets 2 pi r plus 2 pi. Well, I guess what we can do here is we can cancel this r with this r and multiply the 12 and the 2, so it looks like we'll have 24 pi over r. So we've got the surface area now r. The surface area is a function of r. That's of r. Okay, I guess we could pull out the 2 pi if we want it, and rewrite it as r plus 12 over r. And we could leave it at that. Okay? And I think later we'll come back and we'll actually optimize that through our calculator.